So first thing I want to pick up from is we talked about two-dimensional arrays, and one of the things we didn't go into is this thing called a ragged array. And so think of this right here where we got two sets of square brackets that says we have uh, a two-dimensional array, but you'll notice over here on this side we've initialized just one of the arrays and the other one is still empty. So what we're going to do is once we've done that, we still need to take care. So the first one's a number of rows. The second box is going to be the number of columns. So look what we do. We say ragged 0, which is the row, is instantiated as a new int 3. That's it's going to have 3 columns. This is row 1. It's going to have 4 columns. Row 2 is going to have 5 columns. Row 3 is going to have 6 columns. So thus you get the ragged array, meaning that each row does not have the same number of elements in it. And so now what we can do is we can actually run this for loop to say the number of columns in row index is ragged index.length. It's going to basically tell, and this is what it's going to look like. The number of columns in row 0 is 3, number of columns in row 1 is 4, 2 is 5, and 3 is 6. So anyways, I didn't want to spend a whole lot of time on that, but just wanted to kind of let you know how you could do a ragged array. Yeah, now I don't want to spend a whole lot of time on this either, but like I talked about at the end of last class, is we can have 3-dimensional arrays, we can have 4-dimensional arrays. They get really super complex, and so I would really try to avoid them. But if you ever needed to, this is basically what it would look like. 3 sets of square brackets, seats equals new double, 3, 5, and 8. So now what we got is 3 sections that have 3 rows and 8 columns. So yeah, it can get really ugly. So, but just again, I would avoid those if you have to. But this next one I just want to talk about. I really don't want to go in too depth about it, but it talks about 2 different flavors of sort algorithms. And the first one is what we're going to call this first sort algorithm is what we call what I call a bubble sort. So think of a bubble inside of liquid, how it kind of floats to the top. And that's what we're trying to do. So if we look, we got 5, 7, 2, 8, 9, and 1. And what we're trying to do is get these in order. And so the way it's going to work is we're going to check to see if the first and the last, which one's bigger and smaller. Oh, well, this one on this end, this one is smaller. It's going to swap them. So now 1 is here. Then it's going to look at the next 2 sets. It's going to look at this one, and it sees that, oh, yeah, the 2 is smaller, so it's going to flip those around. And then it's going to do the same thing for the third and the last. Which one's smaller? It's going to put that in that column. Then it's going to look at the fourth and the last and flip those. And then it's going to look at the last 2 and basically flip those. And so this would be the algorithm, what we'd look like in pseudocode, and then you could actually convert this into Java. But so this is the algorithm you would use, and there's an actual code for it. I would highly suggest if you're looking for something like this, I would go out to the internet and actually look for a sort. Bubble sorts are very, very slow, and what do I mean by that? Let's say we've got 10,000 records. And you're going to look at the first record and the second record, and you're going to kind of keep moving things around and it would literally take, I mean, a computer would run pretty quick, but as far as computer seconds, it's going to use a lot of computer time doing this bubble sort. Now, what kind of sort we would rather do instead is one called a binary search. Now, what you have to do with the binary search, well, the first one's a sort, this is a search. So really 2 different things going on here. So we got a sort and a search. So the very first thing we got to do is we got to put things in sorted order. So once we have things in sorted order, if I'm searching for something, once it's in sorted order, what I'll do is I'll take that section of data and I'll cut it in half. And I'll say what I'm searching for, is it in the top half or the bottom half? Oh, it's in the bottom half. it will just take that bottom half, cut it in half, and say, is it in the top half or in the bottom half? Oh, it's in the top half. It'll take that small chunk of the top half, cut it in half, and keep doing that. I think it can divide. I think it's 7 times, and it can actually drill down very, very quickly for searching for things. So bubble sort, and then a binary search. Again, I'm not going to do a whole lot of time on that, but just realize those are 2 things that we can utilize. And I think, yeah, they've got the pseudocode here, and then here is the actual code you can utilize if you wanted to do again, to use the binary search, it has to be in sorted order first. Okay. I don't want to spend a whole lot of time on this next one either because it's command line prompt, and it's really hard to get it to get it set up. But we can actually run this from a command line. I can actually go to my I can actually run it from a command prompt, and so I can actually type in Java, blah, 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 type in the program, and then I can type in parameters, and that's where these things come into play. The string args, that's from a command line prompt. So if I were to basically run this particular item and basically type some things in the, so for example, I would write Java command line, how does this work? And it would actually take, because what it's going to do, it's going to take these arguments and split them into separate lines, and it's going to put how does this work. So that's basically what that. So again, it's really hard to get set up, and it's kind of rarely used. But just realize we can use the command line to run Java code, and again, that's in our public static void main. That's where these things basically come into play. This next one is kind of wild. It's called a variable length argument list. So we're going to say result equals sum 10 and 20. So sum is a method that we're going to call, and this is basically what it looks like. So I've got int first val equals 1, second val equals 2, third val equals 3, fourth val equals 4, and then I'm going to put result sum first val, second val, third val, fourth val. But look at up here, I've got sum 10 and 20. Well, how does it know? I mean, normally we would see an error because it would say, oh, you don't have enough parameters, and this one down here would say, yeah, you got enough parameters. But what we're going to use is this thing called variable length argument list, and the way we do that is I say int, or it could be double, or it could be float, whatever the case may be. But in this case, we're using integers. I type int dot 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 space and then the variable that we're basically utilizing. Now, the only way we can now think of this as an array. Okay, that's an array that we're going to basically utilize now. Now, we don't know how, so whether I passed it 2 or I passed it 4, we don't know. So what we have to utilize is an enhanced for loop. So in this case, I'm going to say for int val. So I'm creating a variable called val. I'm going to take this numbers. I'm going to take each element one at a time and throw it into val. I'm going to say total plus equal val, and then I'm going to return the total. So whether I put in 2 parameters or 4 or 6 or 8, this can handle it because this tells it, these 3 dots say, this is a variable argument method. So a variable length argument list. So it basically says you can throw as many different types of sets of parameters or arguments, and I'll be able to handle it. I haven't seen this so much out in the real world. I'm sure it's used, but I haven't seen it used that often. So yeah, so here is the, let's take a look at it's called var args demo 2. So let's take a look at that. So var args, let's take a look at var args demo 1 first. Let's look at demo 1. And so here I've got int result, and result equals sum 10 and 20. So I look down here, and I've got sum int dot 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 numbers. I've got total, and I've got a local variable for this method called total. I initialize it to 0, and then I use an enhanced for loop to grab each one of these elements out of this array and put into val. So there's 10 and 20, and there's 10, 20, 30, 40, 50, 60. So when we run it, we see 10 and 20 is 30. We see 10, 20, 30, and 40 is 100. And 10, 20, 30, 40, 50, and 60 is 210. So, really nice way to make sure that, hey, I don't care how many arguments you have, we're going to handle them. Let's take a look at varargs demo 2. And what this is doing, this is actually utilizing a object, a bank account object. We've got account 1, account 2, account 3. And so it's going to basically utilize the bank account, and it's going to create 3 different objects. And it's going to have a starting balance of 100, 500, and 1500. So then we got double total, and we're going to say total equals total balance account 1. So what is account 1? That's basically this one object up here. And so it's going to, now notice we're just passing 1 to total balance. So it comes down here and it's going to basically get the balance for just that bank account 1. The next one says total equals total balance account 1 and account 2, and it's going to basically go in there and get the balance from those two and add them together. And then the third one says, hey, we're going to pass the 3 different objects, account 1, account 2, account 3, and then it's going to basically total those up. And again, one method can handle all 3 different of those calls because it says I can handle varying arguments. In vararg demo 3, we've got course average, intro to Java. Now look at this one. This is kind of wild. It's got a string and then 1, 2, 3 floats. This one's got a string and 1, 2 floats. So we come down here, look at that, we got string course and then double ... courses. So it's expecting only 1 string to be passed and then different numbers of elements, arguments for the scores. And so that's basically what we have to then put into the enhanced for loop is double S scores. That's going to total those up. So we aren't just tied to the double being passed in with multiple arguments. We can actually also have different arguments coming in as well. If we take a look at varargs demo 4, now we've got int results, and here I am creating an array and initializing it as 10, 20, 30, 40. And I've got results equals sum 10, 20, and print the results. And then I got sum 20, 10, 20, 30, 40, and it's going to print the results. So we've seen that happen. And then I'm going to say result equals some values, print results. Look at that. So when it basically gets passed down to sum as an array, it's already, so, because remember, these over here, when I pass those 4, it's going to basically be passed down here as an array. But right here, I'm actually passing an array, and so it's basically already an array at that point, and it's going to work the same exact way. So it doesn't matter if I just pass 2 sets of numbers, 4 sets of numbers, or an actual array, it can handle it with the variable args method. Any questions? I'll take your silence as a no. Okay. Now the last part of this chapter talks about an array list object. So up to this point we used an array. An array is immutable, meaning once I set, remember I said I create a bookcase and then I put the number of shelves in there. Once those shelves are set, I can't add any shelves, I can't take away any shelves. So if I've got it set to 6, it's 0 through 5, and there's no taking away any of them. Well, with a new array, a list object, we can add bookshelves and we can take bookshelves away. So what we have now is what's called an array list. Now, it's going to look kind of funny. This is the new style of Java. We say array list. Now, that is the class we're using. But it says, what is the data type that you want this array list to be? And that's what we put in these greater than and less than, or less than and greater than symbols. We put in, we're going to basically make this a string array list. The name of the array list is called name list, and it's going to be instantiated as a new array list as a string data type. And again, since this is an object, we always have to have these parentheses because that is the constructor. And again, this is a no-arg constructor, but again, we must have those whenever we instantiate an object so that it calls the no-arg constructor. Now, to add items to an array list, we just say add. Okay? Add James, add Catherine, add Bill. So this first line, when it executes, it's going to create a bookshelf and put James on it. The next line is executed, it goes ahead and creates another bookshelf and adds Catherine. The next line, it creates a third bookshelf and adds Bill. Okay, I think we've actually got, yeah. So let's open up Array List Demo 1 and let's take a look at it. So here's what we got. We've got array list, less than, string, greater than. That basically all that is saying this is the data type of array list we are creating. The name of the array list is, the name of the array list object is name list. We're going to instantiate it as a new array list, again, string data type, and then left and right parenthesis. I do my add. Now watch this. When I type a period after this name list, look at all the different methods that I have access to. And there is a ton of these. And we're going to use just a few of them tonight, but just realize there's a lot more that's going on there. So the add, okay, so on line 16, it's going to add a bookshelf and put James on it. Line 17, it's going to add another bookshelf, put Catherine. The next one is going to add a third bookshelf and put Bill. And then I'm going to say, the array list has name list dot size. Remember with arrays, we use dot length. Dot length was the built-in method to get the number of elements in an array. With an array list, we do size. And again, that is a method because we can see it's got left and right parentheses. Then I'm going to do a for loop as I do the int index equals 0. Again, that gets executed only once at the very beginning. And then this is the check at the beginning of your loop. While the index is less than the name list dot size, we're going to go into the loop. At the end, we're going to add 1 to the index. We're going to print name list dot get index. Look at that. So here's another method. This is an array list method called get. And I put the index in there, and it's going to retrieve that bookshelf number. So the first time through, it's a 0, so it's going to grab James. Next time it's a 1, it's going to grab Catherine. Next time through, it's going to grab Bill, number 3. So let's go ahead and run this guy. And look at that. The array list has 3 objects stored in it. That's this line right here. And there it is, James, Catherine, and Bill. So we got introduced to a new array list object. We utilize the .add method and the .get method, and also the .size method. Let's open up Array List Demo 2. And again, same exact thing. We got our array list, name list, instantiated as a new array list, against a string data type. We add James, Catherine, and Bill. We say the array list has name.size object stored in it. This time I'm going to use an enhanced for loop. And I say string name. So I'm creating a brand new variable name. And I'm going to go through this name list one element at a time and put it into name. And then I'm going to print out that name. I should see the same exact results as I see down here. So let's run it. And, ooh. What the heck is going on there? Okay, I'm going to close this for a second. Something happened. Let me reopen it. But array lists are a lot more powerful than just a regular normal array. Again, the reason being is we can add things to it, take things away, and so it's a lot more dynamic. So we're not stuck with just one size array. You know, once I set it to 6, I can't add it, change it, or do anything else. Something's coming up. Let's see. Okay. That's that one. Let me open up. ArrayList Demo 2. And let me run it. Yep, there it is. The array list has 3 objects in it, James, Catherine, and Bill. So it uses this enhanced for loop to get each element out of this name list, put it into name, and then we print the name. Let's open up ArrayList Demo 3. And same exact thing. We create our array list. We add the 3 names. And then we go through and we're going to basically do this. We're going to display index name. So we're going to display all the names. So do int index 0 index. Well, the index is less than the name list size. We're going to go into here. I'm going to say index, print the index, the name, and I'm going to say get the name via that index. So we should see James, Catherine, and Bill. Now look at this. Now I'm going to do dot remove the number 1 element. James is 0, Catherine is 1, Bill is 2. When I remove 1, it's going to remove Catherine. And it says the item at index 1 is removed. Here are the items now. Now it's going to do that same exact for loop. Now, when I removed element 1, Bill was 2, Bill now becomes 1. So James is 0, Bill is now 1 because Catherine's been removed. So now when I go through here, it should just print James and Bill. Okay, so let's run it. And there it is. Index 0, James. Index 1 name, Catherine. Index 2 name, Bill. The item at index 1 is removed. Here are the items now. Index 0 name, James. Index 1 name, Bill. So again, this is why array lists are so powerful. We can remove things, and it doesn't affect the array itself. Again, we can't do that with a regular array. We're not stuck with that number of elements. Let's open up ArrayList Demo 4. Same exact thing. We create an array list. We add those 3 names. We then display all the names. And then this time I'm going to say namelist.add 1 Mary. So what it's going to do, in this one, it's going to add. Now where's it going to add? Think of it adding between James and Catherine, because James is 0, Catherine is 1. It says I want to add a new number 1 element, so it's going to push Catherine and Bill down. And once it adds this, James will be 0, Mary will be 1, Catherine will be 2, and Bill will be 3. It's going to say Mary was added at index 1. Here are the items now. It's going to display them all again. So this is what it looks like. Index 0 named James, index 1 named Catherine, index 2 named Bill. Mary was added at index 1. Here are the items now. Index 0 named James, index 1 named Mary, index 2 named Catherine, index 3 named Bill. So we've got .add, we've got .remove, we've got .size, so .get. So we've got a lot of things we can utilize to add, remove items from an array list. Let's open up ArrayList Demo 5. So same things here. We got ArrayList. We create an ArrayList. We add the 3 names. We display all the names in the ArrayList. Then I say namelist.set 1 Becky. I had .add 1 Mary. This is set 1 Becky. .add will add a new bookshelf. .set says I'm going to replace whatever's in element 1 or on bookshelf 1, and I'm going to replace it with Becky. So in this particular 928, it's going to replace Catherine with Becky. So .set. Catherine was replaced with Becky. Here are the items now, and it's going to display all the names in the array list. So let's run it. And there's index 0 named James, index 1 named Catherine, index 2 named Bill. Catherine was replaced by Becky. Here are the items now. Index 0 named James, index 1 named Becky, index 2 named Bill. So .set. So .add adds a new bookshelf, and then we add that name. .set says replace whatever in that index. Any questions so far? And let's take a look at ArrayList Demo 6. And there we have, we create our array list. Now this time we're adding objects, okay? So up here I've got array list bank account. It says I'm creating an array list of bank account objects. The previous one was string objects. This is bank account objects. We're going to call it list, and we're going to instantiate it as a new array list of bank account objects. And then the left and right parentheses for our no-art constructor. I say list.add. I'm going to instantiate a new bank account object with $100 for that constructor. I'm going to do list.add. I'm going to instantiate another bank account object. I'm going to instantiate it with $500 for the constructor. And then I'm going to do another list.add, instantiate another bank account. It's going to have $1,500 being passed to the constructor. So when I get done with that, I now have an array list of 3 bank account objects. The first one has $100 balance, the next one has $500 balance, the third has $1,500 balance. Then I'm going to go through a for loop by the list.size, and I'm going to create. So look at this. Down here I say bank account equals list.getIndex. So remember what this guy does? This creates the object. This on this side instantiates it. Now right here is where it was instantiated. So when it says get, that's where it does the instantiation. It puts it into this account, and then I can say the account at index, whatever the index is, new line balance, and it's going to say account.getBalance. It's going to come through this loop again and grab the next list item, array list item, and basically put that into account. And it's going to display the balance. It's going to go through it again, grab the next bank account object in the array list, and do the same. So let's run it, and then we have account at index 0, balance is $100. Account at index 1, balance is $500. Account at index 2 is $1,500. So really, whenever we create an array list, we can create an array list of basically anything. We can create an array list of integers, doubles, so on and so forth. On page 480, we have this thing called the diamond operator for the type interface. So it says beginning with Java 7, version 7, we can simplify an instantiation of array list by using the diamond operator. So for example, in this chapter, you've seen several programs that use the ArrayList object with the statements such as ArrayList string, inventory item, bank account, whatever the case may be. Again, this is brand new to the latest version of Java, starting with Java 7. So they call that the diamond operator. So that's what this, I call it the less than and greater than sign, but they call it the diamond operator. So we're going to see more of this and other items as we get into Java 2. We will see this diamond operator used more often. Okay, why don't we do this? Let's go to well, let me ask you this. Do you guys feel like doing a homework assignment? I mean, working on an exercise? You guys want to call it a night?